hot oil flushing, hydraulic systems and lube oil systems. Hydraulic systems are extremely sensitive to contamination, so achieving the required standard of cleanliness is paramount. Anecdotally, it is reckoned that perhaps 75% of the downtime with hydraulic systems can be attributed to contamination. Cleanliness is important because these are critical systems in the operation and control of the facility. For an oil of a given kinematic viscosity at a temperature of around 40 to 65 degrees Celsius and at a velocity higher than that at normal operation to ensure turbulent flow, as calculated in the flushing procedure, oil is flushed and filtered through the hydraulic systems until the required standards are attained. In theory, this can be performed either by construction or commissioning, and see the recommendations later. But it will be necessary and will take time, running into several weeks on most projects. There are various standards in use in the hydraulic industry, of which ISO, NAS and SAE are probably the most common. These standards relate to the size and quantity of particles passing filters of decreasing size. Liquid particle counters are used to determine the quality of the liquid passing through them. The size and number of particles can determine if the liquid is clean enough to be used for the designed application. Each project will specify the degree of cleanliness to be attained. The commissioning manager needs to decide early on by whom and when hot oil flushing will be performed and plan accordingly. Remember, the objective is to attain the required cleanliness standards in the least time and at the least expense. Considerations are where in the project schedule to fit hot oil flushing, the extent of lube oil and hydraulic systems on the project, and the quantity of oil needed to attain the required standard. Further considerations are equipment needed, hiring a specialist contractor and his attendance on site, the bed space and a budget, of course. The clear advice given here is to schedule the work as a static commissioning activity within the scope of the B check sheets and hire a specialist contractor who will provide all the personnel, the pumps, the hoses, laboratory with measuring equipment and the cleaning fluid. The photo on slide 282 shows an oil flushing rig operated by IKM, a well-known specialist in commissioning and testing services. All A check sheets for hydraulic and lube oil systems are to be completed with no outstanding Category A punch list items or MOCs carried over. All B check sheets for leak testing, hydraulic and lube oil systems are completed and Category A punch list items or MOCs are also completed. Look at the photo on slide 282 of a human hair and the size of particles on the filter. This is what we are attempting to remove. The fluid sample size used to determine cleanliness is proportional to the total volume of fluid in the system. When the required cleanliness standard is attained for the system, commissioning retains custody until final handover to operations. Slide 284 has two images of oil flushing rigs and contains two embedded files. One is a useful handbook from Pole Corporation and the other an interesting paper from GE on cleaning, flushing, testing and commissioning of piping systems, including hydraulic flushing of critical systems. Slide 285. Look at the table of ISO and NAS standards for rotating equipment. Note, in the oil and gas industry, a commonly quoted specification is NAS Class 6, or more commonly known as NAS 1638 Class 6, which equates to ISO 4406, Class 17, 15, 12. Slide 286. Refer to the graph of kinematic viscosity versus temperature. On the x-axis are the lower and upper temperature ranges of 40 degrees Celsius to 65 degrees Celsius. This is 105 degree F to 150 degrees F. On the y-axis are the lower and upper kinematic viscosity ranges of 8 to 20 centistokes. The diagonal isobars show the cleanliness specifications with NAS Class 6 shown in yellow. Note, a commonly quoted temperature specification is 50 degrees C or 122 degrees F, but the actual temperature will be determined by the specified cleanliness standard and the hydraulic oil specification. Hence, the actual temperature is likely to come within the range shown on the graph. Slide 287. On this slide is the important background and essential theory behind hydraulic flushing. In summary, it is important to achieve turbulent flow with a Reynolds number of at least 4,000, and this requires a sufficiently sized test rig to attain the velocity needed. Note, the use of hot oil is particularly important for removing any free water present in the piping or tubing system, because at higher temperatures the water droplets effectively dissolve into the hydraulic oil.